Alright, today we have permutations and combinations. Today's lesson's all about different ways and different techniques we can count a lot of things very quickly and efficiently without actually writing out all of the options. So there are kind of three main things that we're going to be using: the fundamental counting theorem, permutations, and then combinations as far as counting things go. So the fundamental counting principle says if event M can occur m number of ways and event N can occur n number of ways, then the event M followed by the event N can occur m times n number of ways. So essentially what this means is you want to do a product or you want to multiply the different options for the different categories. We're going to see that here in a few minutes on a few examples. So hold on to that thought. Alright, before I talk about factorial, I want to talk about permutation combination. Permutation is arrangement of items in which the order is important. So for example, if I want to figure out, if I have 12 people in a race and I want to figure out all the different ways that they can come in first, second, and third, that would be considered a permutation where the order is important. So you're picking 3 places out of the 12 people, and then there's a couple of techniques we're going to learn on how to figure out all the different combinations for that. And then you have something called a combination. A combination is like a permutation, but it's where the order is not important. So instead of like first, second, and third, you're like saying I think we see an example here in a minute where you do like a jury duty. You select a bunch of jurors, so like maybe there's 15 people to choose from, and you're choosing 5 people to be on the jury. So it doesn't really matter on the order that they are selected in, and usually those numbers are a little bit smaller than the permutations. Okay, count methods can be used to find the number of ways to choose objects from different sets. You can use these counting methods to find the total number of outcomes in the sample space. So here's an example with the fundamental counting theorem. You already kind of read it, but so let's say you have a menu with 4 entrees and 6 drinks. You have 2 categories. You take the total number of each category and you multiply them, so you get 24 possible different types of lunch specials there. Okay. Oh yeah, and factorial, forgot to go over that. Factorial is a product of the integers from n down to 1. So we're going to use factorial to help ourselves compute some of this here in a bit. So that's like, for example, if you have this thing right here, it's called 5 factorial. It's like a 5 and then with the little exclamation mark. That's like saying the product of 5 times the next number times 4 times the next number 3 and then 2 and then 1 at the end. And that is what factorial is. And we use it in permutations and combinations quite a bit. So that kind of says all of that right there. They got 4 factorial there, so 4 times 3 times 2 times 1. And it's just, the first number is usually that's what you start with there. Alright, so there are 2 formulas using the factorials for permutations and then combinations. So these are the 2 formulas. Alright, so this is if you have a set of R items and then you are picking if you have a set of n items and then you are picking R number of items. So this is like how big the group is, and then this number here, R, is what you're picking, like how many of you are picking. Okay, so it's this formula. Now I'm going to show you guys with the graphing calculator how to type that in. But that right there, there's actually a button in your calculator and where you go and fill in the N and the R, and then it'll punch it out for you. But if you want to figure out kind of like where it comes from here, this basically you take 8 factorial. If you're doing, I guess, with this example, you're doing from a group of 8, you're picking 3 items. So you do 8 factorial in the numerator, you do 8 minus 3 factorial in the denominator. Notice here that these 5s, 4s, 3s, 2s, and 1s are all going to cancel out. So it's kind of like saying 8 times 7 times 6 right there. The reason that works, like say if you're picking 3 things out of your group of 8, you have 8 options for the first place or the first slot that you're going to do. After you pick that, you only have 7 options for the next slot. And then after that, you only have six options for the next slot there. And that's kind of where it comes from, but we'll use our calculator quite a bit on that today. We're not actually going to write out all the formula stuff. You can if you would like to, but we're really not going to use that a ton. Now, combination, very similar. Remember, this is when order does not matter. Okay, so it's a little bit different here. Notice you use N and R again, but then they use the C here for the combination. C stands for the combination. And the formula is a little bit different. Instead of just doing N over N minus R factorial, you also multiply the denominator by whatever R factorial is. So in this case here, they use out of 9 things, they're going to pick 4, where the order doesn't matter. So essentially all this stuff kind of cancels out again. The 5, 4, 3, 2, 1s right there. Those are all going to cancel out. But then you still have 9, 8, 7, and 6. And then in the denominator, you're going to have 4, 3, 2, and 1 right there. So anyways, since you're dividing by more, it's going to make the number of items going to be smaller right there. And I'll show you here in a second how to punch that out on your calculator. Okay. So let's start using some of our counting techniques here. So you have a deli offers a lunch special if you choose one from each of the following types of sandwiches, side items, and drink choices. How many different lunch specials are there? So I'm looking here, and you have looks like 6 options for the first for the sandwiches. It looks like you have 4 options for the side items, and then 5 options for the drinks. And like we said, all you got to do when you have multiple categories is just multiply those numbers. So we're going 6 times 4 and then times 5. And I guess that's 120. Probably small enough to where we could do it without a calculator, but use a calculator to speed yourself up. And that's all you do right there. That's how to find out all the different options that you have for your different lunch specials. Okay, next one here. You can download 8 songs on your music player. If you play the songs using the random shuffle option, how many different ways can the sequence of songs be played? So this here, we have 8 songs. So imagine for the first song, whatever the first song is, you have 8 options for that. And I'm not saying divide by that. I'm just kind of saying, I guess the first song, here, let's do it like this. Let's go first. You have 8 options. So then after you play the first song, whatever it is, you automatically now only have 7 options. All right, and you're going to take those, you're going to multiply those numbers. And after that, for the third song, you're only going to have 6 options. And then the fourth song, you're going to have 5 options. And you're taking all these numbers and multiplying them. So actually, this is that thing called factorial. You can go all the way down to 1. And that's basically equal to 8 factorial. Okay, now we're actually going to punch this out, whatever it is. But I want to show you, or at least tell you how to get that into your calculator. If you're using a TI-84, if you don't have a fancy graphing calculator, you might need to look up the instructions how to do factorial if that function exists in your calculator. But if you're using a TI-84 or TI-83, you can hit the math button. Then you're going to scroll right to probability. It just says prob. So math is under alpha. So if you're looking for that button on the left side, go to probability. You're going to scroll over. It's a couple clicks over. And then the fourth option down has the exclamation point. So that's option 4 if you want to write that. And that will get you the little exclamation mark or the factorial. Now, a key thing you got to do first, you actually have to type 8 first. So you're going to type 8, then you're going to go math, probability, get your little exclamation mark, which is factorial, and that'll punch that out. So I am going to do that myself real quick. 8 factorial. So when you multiply all of those numbers together, it actually winds up being a gigantic number. It's going to be 40,320. That's all the number of ways you could listen to those 8 songs in a random order. That's all the different possibilities right there. So obviously we wouldn't want to write out every single possibility if we wanted to count them up. So these fundamental counting theorems and the permutations and combinations speed up that process. And they use that a lot with probability and figuring out the odds of something happening. So this will all kind of tie back into probability and stuff. Same kind of question right here, maybe different numbers. How many different ways can you arrange 12 books on a shelf? It's very similar to this, where the first option, you're going to have 12 options for the first slot. And then for this slot next to it, you're only going to have 11 options because you already placed one. And then keep going, 10, and then times 9, and then dot, 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 all the way down to 1, which is basically 12 factorial. All right, remember to type that in. You're going to type in 12 into your calculator. You're going to hit the math button, scroll to probability, and then fourth option down should be that little exclamation point. And that is some giant number here, 479,001, and then 600. So if I get all my comma places in the right spots right there, that's 479 million options right there, which is quite significantly high. So very, very many different options on that. Now, as far as permutations, we're going to try those here, and then we're going to try out permutations, and then try out combinations. So, anyways, student council is electing a president, a vice president, and a treasurer. So you're selecting 3 different positions. How many different ways can the officers be chosen from the 10 members right there? So we use a permutation in this case because the order matters, because you have unique positions there. Not every position's the same, so they're all unique, so the order in which you pick them matters. So we use what we call a permutation. All right, so since you're picking out of 10 members, you put your bigger number on the left side, and then you're only picking 3 positions. All right, now you can follow the formula in your calculator, or you can write out all the numbers and stuff like that. But if you want to do it in your calculator, don't worry about this here. You're going to go and hit math. You're going to scroll to probability. So I'm going to do that here, probability. And then the second option down, looks like that here. I should put that in parentheses. Second option is this thing right here where it says N, and then it's got a big P and then an R. And then you can literally type these numbers that you have in to the NPR formula. Alright, and then instead of doing all this stuff that we saw here on the previous pages and writing out all the formulas, your calculator is going to tell you what that answer is. And the reason I like that, if you're going to do all this stuff right here, 10 factorial and then divided by 10 minus 3 factorial, you're probably using your calculator anyways, so might as well just use the thing in your calculator that just punches it all out for you. So it's as easy as that. So we got 10 things we're picking from. We're using a permutation, so we use the P, and then we're picking 3 items there. So I'm going to do that here real quick, so bear with me. 10, and then you just press over, and then you type in 3, and then that gets you 720 right there. So it's all out of the calculator. Okay, and that's all you do there. Alright, so anyways, let's do this here. Next thing, 12 swimmers compete in a race. How many possible ways can the swimmers finish first, second, and third? So this one is also going to be a permutation. So we're going to use the P thing again. And now you have 12 people that are participating. And you're doing first, second, and third place. So you have 3 different positions that you're placing there. So I'm going to punch that out in my calculator again. And apparently you get 1,320 different ways that they can finish in first, second, and third. So pretty high amount right there. Alright, now combinations, these are next here. Combinations, remember the order does not matter on these. So if you want to write that down again, know we've written that a few times. Order does not matter. Okay, so suppose your school requires you to choose 4 books to read on summer vacation from a reading list of 12 books. How many different ways can the books be chosen? So you have 12 options. We're going to use a combination instead, and then you got 4 things there. So once again, we're just going to use our calculator. Now, when you go and you hit the math, and then you scroll to the right and you find probability, it's a different option. I think it's the third one, if I am thinking correctly. Yeah, it'll be your third option. And then you're going to do the NCR option. Alright, and that's the third one. Third on the list. So we're going to type that into our calculator. And then 12 is the big number. The big number always goes on the right. Or I'm sorry, on the left. And then the small number on the right hand side. That's going to get us 495 options. Right there. Okay, so a little bit lower of a number, like compared to the 12 swimmers and the 3 positions. When the order doesn't matter, the number goes drastically down. Okay. Alright, and yeah, don't worry about this right here. It's kind of a different thing there. So anyways, let's look here. Service Club has 8 freshmen. 5 of the freshmen are to be on the cleanup crew for the town's annual picnic. How many different ways are there to choose a 5-member cleanup crew? So there are 8 people, and we are picking, what are we doing? 5. We're picking 5 from that 8. And since they all are going to have the same job, the order does not matter, so we use a combination. So we're picking 5 out of 8 from a combination because the order does not matter. So then I'm going to punch that out here on my calculator. And that only gives us 56 options. So obviously the more you pick right there, it's not going to be as many different options there, especially since the order doesn't matter. Okay. Alright, next, how do you know when to choose a permutation or a combination? It's all based on the order. We've said that a bunch of times. The order matters for permutation. So whenever you have a permutation, you got order that you need. Combination, the order does not matter. So I think with these next few here, we're just going to identify if it's a permutation or a combination. We'll just put a P or a C for those. So think about this. A college student is choosing 3 classes to take during first, second, and third semesters from the 5 elective classes offered in his major. How many possible ways can the student choose the 3 classes? Now, since they said the first, second, and third semesters, the order definitely matters there, so we use a permutation for that. And actually, if you wanted to go punch it out, we're picking 3 things from how many? 5 elective classes. So you could go and punch out that number. They didn't ask for that in this case, so we'll just move along, but that's what you would do. Okay, a jury of 12 people, there's that jury one I was talking about, is chosen from a pool of 35 potential jurors. How many different juries can be chosen? So right here, since you're doing a jury and everyone's position is pretty much the same, we say the order does not matter in which you get picked, so that's a combination. So there's 35 of those right there, and then I guess you're picking 12. Then you can go use your calculator to punch it out. A yogurt shop allows you to choose any of the 10 possible mix-ins for the smoothie. How many different smoothies are possible? So the way I think this one through is the order doesn't matter in which you put your toppings. We're going to assume that at least. So you have 3 options, but you're choosing from 10. So that's a combination. Again, that's that. Now I think these ones they actually wanted us to solve. If you want to go find the numbers there, you definitely can. It's really not hard if you have a calculator. So, all right, let's look here. When shopping to buy a new car, Johnny decided to buy a Honda Accord. The Honda came in 5 different colors, 2 different sizes of wheels, and 2 different types of interior. So actually this is going back to some of the first few problems where we had different categories. Anytime you have different categories, all you got to do is take them and multiply them. So 5 times 2 and then times that by 2. So I think that's 20. There are 20 options. Okay. Now, we only use permutations and combinations when you're actually going through and picking from a group of things. You're picking a group out of a group. Here you have categories. Categories means you just multiply them all together. Okay, let's see here. There are 10 different fish in a pond. If Sally chooses 3 of them out of the pond, how many different combinations are there for those 3 fish? So they kind of tell you it's a combination right there, but also if you think about this, the order doesn't really matter in which the fish get picked, so we're just going to use a combination there. So there are 10 of them, and there are 3 of them that we are picking there. So I'm going to punch that out here real quick in the calculator. So 10 and then 3, so that gets us 120 options right there. Okay, what about this? 8 runners are running in a mile race. How many different ways can they finish first, second, third, and fourth? So this one is definitely a permutation. The order matters because they kind of said it's first, second, third, and fourth. So you got 4 places out of 8 runners. So I'm going to type that in here real quick. Bear with me. 8 for the big number, 4 for the small number. And then you get 1,688. Always get this question: what happens if you accidentally put the small number and then the big number? It's just going to tell you the probability or the number of options that works is 0. It's like kind of saying if you accidentally switched them and you had 4P8, that's basically saying pick 8 things from a group of 4, which doesn't really make any sense. So there are no ways that can happen. And your calculator will tell you that, but it's pretty easy to figure out if you typed it in wrong. All right, look at this one. There are 10 songs on a new Bruno Mars CD. If it is played on random shuffle, how many different ways can the top 10 songs be played? Okay, so actually this is kind of like going to the factorial thing. You have 10 for the first option, 9 for the next option, 8 for the next option, all the way down to 1. So that's the same thing as 10 factorial. Now some of you guys might have been thinking, well, hey, aren't there 10 places that we're choosing and then we're choosing 10 songs? And yes, that's true. So you could also use a permutation and you're picking 10 out of the 10. Alright, and then if you do that in your calculator, let's see, math, probability, factorial, that comes out as a giant number here. That's 3628800. Alright, a couple more here. There are 16 teams that made the basketball tournament. How many different ways can they finish first, second, and third? So that's a permutation. Going 16 with the small number, 3 with the large number. I think my bell's about to ring here. So hang there with me on that. So 16, so that'd be 3,360. And last one, teacher lets you work 10 problems for homework out of a total of 30 problems. How many different possibilities are there for students to choose 10 problems out of the 30? So the order won't matter there, so I'm going to use a combination. We're going to use 30 for the big number and then 10 for the small number. You're only picking 10. And then let me punch that out. 30 and then 10. So that's a giant number here. 45015. So that right there is 30,045,015 options. So anyways, that is it for our lesson.